So this set of notes is going to be on solving quadratics 3 ways, because we've been seeing some quadratics, should be reviewed from integrated 2, but I want to make sure we all understand. So solving quadratics by zero product property, completing the square, and quadratic formula. So the zero product property is the following. And we kind of did little notes on this, but I just want to add everything together. If A times B equals 0, then anytime we multiply two things together and get 0, one of them has to be 0. Then A equals 0 or B equals 0. And when I say or, it could be A, B, or both. Okay. So what we want to do is we want to get quadratic equal to 0 and factor. That's our goal. Okay. So let's say, for example, we have the following. So the final one, it's going to be nicer. So let's say we have x squared plus 6x plus 8 equals 0, something like this. Okay. So this is equal to 0. If it wasn't, I would get it equal to 0. And then what we're going to do is factor. This one here is just a plain old diamond. So I really want something to multiply to 8 and add to 6, which is going to be 4 and 2. So my factors are going to be x plus 4, x plus 2 equals 0. And we're going to set both of them to 0. So when I set this to 0, I'm going to get -4. When I set this to 0, I'm going to get a -2. And that's our answer. Now, let me give us one that maybe isn't as nice, where we have to maybe use a box to diamond. So let's say we have 2x squared minus 7x plus 6 equals 0. So one like this, I would do a box to diamond. So let's say about my 2x squared here and my 6. When I multiply those together, I'm going to get a 12x squared, and it has to add to a -7x. That's going to be a -4x and a -3x. So I'm going to have a -4x and a -3x. Then what I'm going to do is I'm going to find the outside. So I'm going to have a 2x here and an x here. -2 to get me a -4x, and x times -3. So my factors are going to be 2x minus 3 times x minus 2 equals 0. Then we're going to set those to 0 and solve. So 2x minus 3 equals 0. I'm going to get 2x is equal to 3. X is equal to 3/2. That's one answer. The other one, x minus 2 equals 0. X is equal to 2. That's my second answer. So these ones are using the zero product property. Now, both of these cases, I had them set equal to 0. If it isn't, just add or subtract to get them set equal to 0. Okay. Next example, let's do the quadratic formula we'll do next. So quadratic formula. So if ax squared plus bx plus c is equal to 0, then you can use the quadratic formula where x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is our quadratic formula. Okay, so you can use this whether something's factorable or not. You can always use quadratic formula. So let's say, for example, we have the following. Let's say we have 4x squared minus 8x plus 13 is equal to 0. So you always have to have it equal to 0. Okay. And then once you do, this is going to be our A. This is going to be our B. This is going to be our C. So I'm going to have x is equal to, when I say negative b, my b is a negative 8, so that means I make it opposite. So it's going to be a positive 8 times the square root of negative 8 squared. Notice I put it in parentheses, minus 4 times my a, which is 4, and my c, which is 13, all over 2 times my a, which is 4. So I'm going to have x is equal to 8 plus or minus the square root. And here, when I do this math, let me just do that math real quick. I end up getting a negative 144 over 8. Since I have a negative underneath my square root, this is going to be imaginary answers. So I'm going to end up getting x is equal to 8 plus or minus, and the square root of a negative 144 is a 12i. Now, when you have this, if you can simplify every single term, you want to do that. So I can divide everything by 4. So I'm going to get 2 plus or minus 3i over 2. And that is my answer. Now, if I was trying to find x-intercepts using this, I would not have x-intercepts because I got imaginary answers. Okay. Now let me do one where we're using the completing the square. Okay. I personally don't like to complete the square on a problem like this one that I just worked out because I have a number in front of my x squared. I like to do it when I have just x squared. You don't like to do it when there's a number in front. And I like to do it when I have an even x. Okay, let me add a page. So this is going to be completing the square. Okay, so let's say that I'm doing a problem like the following. X squared plus 6x plus 41 is equal to 0. So I like to do it again when I have an x squared, not like a 2x squared or a 3x squared. I also like to complete the square when I have an even x because it makes it a little easier. And we want to try to make this into a perfect square. So a couple ways to do this. One way is to literally do a box, okay, and we want a square. So what I generally do is this 41 is not making a perfect square. So I'm going to actually subtract the 41 to the other side. Okay, and then I want to figure out what I'm going to put here. Whatever I put there, I'm also going to put here. So what I'm going to do is I'm going to have x squared, and then my 6x needs to be split evenly because I want it to be a square. So if I split 6x evenly, it's going to be a 3x and a 3x. So then if I'm trying to find this outside, this is going to be an x plus 3 This is going to be an x plus 3, which means the missing piece has to be 9. So this is going to be a plus 9. This is going to be a plus 9. Another way to do that, let me just see if I can move this. Just trying to move that over. Another way I could do this is also think about this 6 as my b, okay? So when I'm doing this, what you want to do is you want to take half of your b and then square it. So my b is 6, so I'm going to take half of 6 and square it. So that's going to be 3 squared, which is 9. And that's what I added to both sides. So now what I'm going to do is I'm going to write it literally as a square. So you'll see in the actual rectangle, the generic rectangle, that you have an x plus 3, x plus 3. So this is going to be an x plus 3 squared. If I was doing it using this b over 2, it's whatever half of your b is. Okay, half of our 6 is 3. On the other side, I'm going to get a negative, let's see, 32. So now what I'm going to do is I'm going to square root both sides. So this is going to be an x plus 3. When I square root this side, I'm going to get a positive and a negative always. Square root of a negative 32. So I'm going to get another imaginary situation. Now, when I'm taking the square root of a negative 32, I can rewrite this. And the square root of a negative 32, you want to think, is there a perfect square in 32? So in 32, let me just kind of jot it over here. You have 32 is equal to 16 times 2. So really, if I'm thinking about the square root of a 32, I can think of it as the square root of 16 times the square root of 2. Now, the square root of 16 is a 4. So I can rewrite this as a 4 root 2. That should be a reminder from integrated 2, but I might jot some notes down on this too. So since this is imaginary, because it has a negative underneath the square root, this is going to be a 4i root 2. So my answer is going to be negative 3 plus or minus 4i root 2. That is going to be my answer. So that's our notes for completing the square.